Greetings! In this video I'm going to document a live problem that I'm having with a unit on my desk, this Tascam 424 Mark III. We can see I've got it open, propped open, turned on, bit of cardboard there, just leave it open. This unit came to me without a door and without a power supply, so I've hooked up a power supply. I had a spare door. The power supply I hooked up basically using the instructions in Third Island's video about the subject. It's mostly working. We've got a couple of niggles. This fader's out, so no problem. When I had that board out for a deep clean, I bothered to deep clean the master fader because it felt a bit rough. The other ones I left because they seem fine. The other 5 are fine. This one, try rebuilding it first. Failing that, I'll just need to find a replacement. I've used my audio probe and the signal is getting from the input as far as the input pin of the fader, but it's not leaving the fader, so there's something up with that fader. Other issue that we've got is a peculiar thing to do with stereo as it's received by the meters and by the headphone socket. I'll try and demonstrate this. So I've got a tape in here. You can hear that there's cassettes playing back. If I turn down this one, I think it's a stereo mic, but certainly in the room, when I turn the pan control, I can hear the sound moving between the left and right speaker. So clearly the master fader is passing signal on both sides. But like when I turn it to the right, even though it's audible, it's not hitting the right side of the master fader. And then if I plug this, can you hear that's coming out of the headphones? Now, I won't be able to demonstrate this properly, but essentially what's happening is, if I turn the level all the way up, it doesn't get any louder. If I put it in mono, it's coming out of both speakers. So both sides of the op amp and, surrounding capacitors related to the headphone are working. But if I put it in line out, then it's only appearing on the left. So what this is telling me, somewhere between the healthy master fader and both the meters and the headphone amp, something has gone awry. I don't really know what that is. I'm going to have to analyse the schematic. I'm over in Photoshop, and this is one of 4 pages from the schematic pertaining to the mixer. But it's this first one. Phone PCB, that's the one we want, 'cause, over here we've got the little daughter board that's got the actual phone socket on it. Headphone socket, I should say, not phone. I've done quite a bit of preparatory work here. I haven't actually figured out which components I want to replace yet. But if I try and turn off everything here, this is what we would normally see. It's this black and white bunch of gibberish, which I personally can't follow without color coding. So I've covered this before in other videos, but what I usually do is treat the path between inputs and outputs like it's a train line, map the London Underground, this kind of thing. If I just make up a new layer here to show you roughly what I'm talking about, if you haven't seen one of the other videos, pick a random socket here. I want to see where ground goes, okay? So I'm going to start there, and I'm going to just start drawing. So there's a junction, so it's going over here, and then it goes up to this positive side of this op amp is connected to ground clearly. And once I've fully annotated one of these, ground would actually be one of the ones that I don't bother to colour at all. I leave that one black, but anyway, I'll bin that. So I turn everything back on. You can see I've colour coded quite a lot of stuff, and in particular I've got these overlaid semi-transparent sections, and that just allows me to group things together by function. So all this stuff over here to the left, these are the individual mixer strips, like this is the input amplifier, that's the switch, the fader's there, EQ's there, and then you've got your pan control here before it goes off to stuff like the master fader up in the top right there. And then I don't know if you can see the kind of crawling ants, but like this bit that I just put in the marquee select there, that's shown in detail, and then they show the second one, the third channel, the fourth channel. They really only show you the differing part numbers. So like this operational amplifier, it's U10. I can't even read that, it's not very well. Is that 2.9? But anyway, it's 2.8 for this channel. It just shows you that the pin numbers are the same to confirm that. There will be a corresponding, for instance, C112 will be C212 for channel 2, it will be C312 for channel 3, and that's why they don't bother to populate the entire schematic for these sections. Anyway, other than identifying the effect cue or tape switch, because I wanted to be sure that I wasn't mixing up with other switches here. I mean, I think I just highlighted all there's the EQ section just to, I don't really know for this purpose why I did that. I mean, it's not wasted work. I might need to diagnose the EQ section on another machine. But, you know, to begin with, for instance, these, let's see if I can make the cursor a bit bigger so you can see it better. Right, so hopefully you can see there's a circle moving around now. So the ones I've highlighted yellow and pink, initially I wasn't sure what those operational amplifiers are for, but they're drivers from the effects sends. And how did I establish that? Well, I found likes of label here where it says EFF1, and then I started from this resistor, drawing in yellow, and then I got to a junction and then it goes into there, and then if I follow that to these other junctions, it comes to the F1 outputs of all these other channels. So I know that that is a driver for the effect one. Notice this pattern that I've talked about a lot coming up over and over. So you've got operational amplifier with various components in the feedback loop, bookended by electrolytic coupling capacitors. We see that again with a pre-knob buffer for the headphone amp. You can see this is the way it's distributed on the page. Make this more appropriate size there. I'm waving the pointer. Coupling capacitor, inverting amplifier, and I'm saying inverting because we can see that it's the negative input of the op amp that's going into. These are controlling the feedback. And then it's coming out of a coupling capacitor to this dual gang. See, that's all highlighted in purple for my own benefit, that both of those symbols pertain to R73, which is the headphone knob. And it's coming at the output of the headphone knob, and there's another coupling capacitor going into the output buffer. Notice that it's an inverting amplifier before and an inverting amplifier afterwards. So if you were to test with an oscilloscope actually at the headphone, you would find that the signal was 180 degrees out of phase. That is flipped on the horizontal axis on an oscilloscope, but then it was back to normal by the time it came out of this amplifier down here. Same patterns up here. This is the master fader, so you can see there's an electrolytic capacitor, then an operational amplifier, then an electrolytic capacitor, then the fader, then an electrolytic capacitor, then an op amp, and then an electrolytic capacitor. So we see these sort of patterns over and over. Here in the EQ section, electrolytic capacitor, really it's the mid gain, it looks like, is what is requiring these op amps. It looks like it's passive for the high and low. This bit here is the high and low, and then this is the mid gain and frequency business here. So you've got two operational amplifiers in series, and then there's a coupling capacitor. Okay, so anyway, I'm going to hide some of that because it's not pertinent to our problem, so hopefully I can make it bigger in post-production, but I've got this organized so all those overlay things are in a folder in the layers. So what do I don't need the EQ overlay, I don't need the take cue effect, I don't need the 7/8 level and assign. I was really just highlighting those to make sure I wasn't confusing them with other switches that appear here that I am more concerned with. Well, the effects I don't really need to see. I didn't find any problem with the effects. So in terms of the actual paths, I can afford to turn off all these connections that are going from the effects send knobs of the individual channels to these two op amps here, they are not of concern to me either. Oh yeah, I don't really need to know about the master fader or the fader. I've established the master fader is working. What I used to do is just make the, say, the right bus all one colour. What I do now is if the signal branches out in several ways, which this does, in fact, I'll just turn off left side for clarity, so we're just looking at all the paths of the right. Then I've got each bit in a slightly different colour and in a different layer, so I can turn these on in order. So that I just turned on the red path, that's coming from the right output of the pan control and going into the right hand side of the pre-fader operational amplifier for the master section. Then if I turn that on, that's where it's coming out of the post fader buffer, and then it's going to the record playback section. I think nothing else happens to that line out. That's just a line out that will just be directed through that board to the RCA sockets in the back. So in fact, I'm going to turn that off again because I know that part of the signal path is fine on the 44 Mark III that I'm looking at. I'll turn that off. Then this I'm more concerned with. It branches off and goes to this switch, which is whether we're monitoring in mono or stereo. Then from there, it travels down to the pre-headphone control buffer here. And then it travels through the headphone amp. So there it goes through that op amp, through that side of the headphone knob, then through this buffer, and from there it goes to the headphone socket. But it's also branching off from the headphone socket, inverted, and it's going down to mon right, which is part of the control section. Now I would need to look at another part of the schematic to figure out exactly what that is, because there's also this bit, so paler pink that just turned on here. It comes out here, goes up and round the corner, and that goes to the record playback section. So that is labelled monitor right. So one of those two that I just highlighted most recently is going to be the signal that's being sent to the meter, the right hand side of the meter. So that gives me a clue. If I can establish by looking at the RP board and the control section, which of those paths is feeding a signal to the right hand side of the monitor meter, which is part of what's non-responsive in this 424 Mark III, then that gives me a very good clue about which components earlier in the chain may be faulty. So I've just been off screen and located the two schematics that connect to the two sockets I was wondering about. I think I've said before that J and P numbers for cables connecting PCBs tend to match. So here you've got J16, so I was looking for a P16 on another board, and here we've got, sorry, it's this one down here, isn't it? J15, so I'm looking for P15 on another board. Let me show you the corresponding symbol. Zoom right in on the two things. So this has got a P prefix, but that's little spikes, whereas this symbol has holes for the spikes. That denotes that there is cable soldered into the board terminating in a connector, whereas the symbol like this where there's just the spikes, that's the header on the board. So cable and connector is a J prefix, header and no cable, that's a P prefix. So on this board, that's bottom PCB schematic 2 out of 4. Over here on the right, we've got P16. So that corresponds to J16 here. So we can see all that's happening is it's going around the corner into the monitor outputs. So this is a duplicate of sound that's going into your headphones, coming out of RCA sockets on the back so that you can, I don't know, connect to a headphone amplifier. That would be one application of that. But in my case, those sockets are fine, so I'm definitely not interested in that one. What I am interested in is this one here, J15, and that corresponds to bottom board 1 of 4 schematic. Here in the left hand corner we've got P15, so the monitor left and monitor right signal there going to some op amps preceded by coupling capacitors, and then their output, if we follow them over, that's a big massive control chip which speaks to the LCD display and the control buttons. You can see that going to OPE PCB. I think that's a contraction of operation PCB. So that's the one that's got the transport buttons and the LCD screen on it. The signal isn't getting to the LCD display, so I can't think that it would be this capacitor or this op amp here that's the problem, or the cable connects or anything, because then the headphone signal would still work properly. It's just that we wouldn't see the bar on the meter. So I think that means we're tracing back from here. So what we've got, we go up, follow this back. It's where it branches off. Sorry, I'll turn that off, turn that back on in a minute. It's where it branches off from the headphone knob, other possible culprits, this operational amplifier, these two coupling capacitors, and the switch. So I've put on highlight layers for the things that I want to check. So I definitely want to make sure that if I feed a signal in there, that the signal gets through here correctly. It's not the first thing I do, but I could check that those resistors are the correct value, but I'm more concerned with the switch preceding it really. I definitely want to check these capacitors. I think it's more likely that it's these ones than these ones down here, because these are after the headphone socket and after where the signal branches off and goes to that big chip that feeds the LCD display. So if I was going to only replace 2 capacitors, I'll definitely replace those. Though if one of them has become faulty, assuming they're from the same factory batch and receiving the same signal, I may as well replace those 2 while I'm in there. And then this little dot is over the R73, which is the 10K A-weighted dual gang knob, which is the headphone output control. I'll see if I can get appropriate readings from that in circuit. If I can't, I'll desolder it and test it out of circuit. I am slightly curious and confused why it's giving me signal in both sides of the headphones, even if something here is down. What I did was I had a look at what the mono path is for this, line out switch. Basically here it's coming in on the left, so it's going to this mono bar, and then it's going down and on down to the left op amp. But it's also at this voltage divider junction here, going round through this loop, and it ends up back in the right hand side, and correspondingly this is the path that the right bus takes when the switch is in mono mode. It goes through here and it reaches this voltage divider here. So as well as going on its journey to its op amp, the signal also goes back through the same loop, where it will go to the opposite side. So basically both op amps should receive a blend of the left and the right bus. That's how the mono switch works, roughly speaking. But anyway, what I will do now is turn off these 2 temporary layers. Make a list of these part numbers. I'll identify them on the physical printed circuit board with little notes to myself about what they all are, like this is pre-buffer, this is post-pre-buffer, etc, etc. I'll do that thing I do sometimes where I have the printed circuit board free from the plastic housing, but then I've got something non-conductive like jiffy bags or something in between the 2 layers, so that the bottom and top printed circuit board don't short out against each other. And that way I can have the system on and turned on, run my signal generator into the input and do some probing to see how far the signal gets. My guess is one of these 2 capacitors is out, but who knows what we'll find. We'll go back to the workbench and figure it out. After a particularly protracted and unpleasant troubleshooting process, I have finally got to the bottom of this. When I was talking earlier about the setup where we've got something non-conductive to stop the top and lower boards touching each other, this is the sort of thing I mean. This way we can have everything connected but free from its case, so I can turn it off and take measurements. I can use my audio probe while it's still turned on. So, a couple of red herrings in here. I was getting really weird readings from the bottom of this op amp. I was getting 8 volts, 9 volts, DC I should say, going into the input of a couple of the op amps, and that sort of threw me in a loop. I was trying to figure that out, and I ended up replacing loads of capacitors which are connected to ground. So I mean, you can see there's quite a few, these little gold ones all around the board. There's other ones that are black, so they're not so distinguishable from the original ones, but that was to try and prevent, I was thinking that maybe like the positive or negative 9-volt rail was somehow getting into the ground, and from there into the signal path and there into the input of the op amp. But I think those readings were just symptomatic of there being something up with the switch. The switch has come out. I've replaced it with one from port 07 just to see if that was the culprit. It wasn't. Another red herring is that the pin numbers that are on the schematics don't actually correspond to the pin numbers on the switch, so I was trying to use a continuity tester to see whether this was working and getting really weird readings about that. So that's all been very frustrating. Eventually, what's caused the problem where it wasn't appearing in the right hand side and where it was disappearing from both speakers and from the meters altogether when I'm in mono mode and the pan control was over to the right. It's just that the signal wasn't getting through the board itself. So this is an example where a very simple problem can cause all sorts of weird things to happen. So basically it gets as far as this point, the right hand side of the signal, and it should end up at this pin, and it's not getting from there to that pin, so it wasn't even reaching the input of the switch. That's all it was. And I mean, I've looked really closely. I can't see where the break is in that track, but it's definitely a break, because by soldering in this jump lead, it now works properly. So you won't be able to hear it, but if I press play, it's channel 2 that's up, so if I turn that to the right, it goes all the way to the right meter. If I turn it left, it goes all the way to the left meter. So that's that fixed now. But that's been a horrible, I mean, how much time have I sunk into that? Probably 4 or 5 hours trying just to figure what that is. Went down a lot of dead ends before I figured that out. What else? The fact that the headphone socket wasn't working, it wasn't responding to the knob turning. That knob just didn't work. I don't really understand how the signal was getting through when it didn't work. I guess it was just sort of locked at a position where a small amount, a quiet amount of signal went through. So the one that's in there, look how it's the wrong height. That's from a port at 03, it's the same value, it's the same footprint, but I've somehow got to figure out how to make this shaft longer so it's accessible through the case. Probably what I'll do is I'll get a scrap one of these and cut a length so it's the right length, and I'll maybe drill down into both sides with an ABS plastic rod and then use a 2-part glue, hold that in place. So that's been replaced, and then the fader looked absolutely fine. It wasn't all that dirty, but it did turn out actually, yeah, it wasn't passing signal at all, so I've had to abandon it. This is actually from a Fostex XR3. It's the right value, it's the right footprint, but you can see that the shaft, although it's the right height roughly, it's a completely different design. This is a sort of slim metal design. This one was a thick plastic one. So what you can see, I've just filed it down with jeweler's files so that the original plastic knob cap for the 424 Mark III will fit on there now. So cosmetically you won't know that it's actually a different kind of fader underneath it. I'm trying to think if there's a lesson, you know, like at the end of He-Man, they have like a moral lesson, or I seem to remember they did. Tila and Man-at-Arms discuss like the philosophy of cooperation or something. I'm not sure. Did I jump ahead into like replacing capacitors and stuff when I should have just done a simple signal trace from A to B to find that? Well, yeah, if I'd gone down that route, then yeah, I would have found what the problem was earlier. Last thing I'll say, if you found this sort of side of things interesting, particularly the interpreting schematics, Something that I'm going to be doing for patrons and Patreon is, as I continue to annotate these schematics, I will be uploading them regularly, both like screenshots and also the raw Photoshop file. So that's a perk if you want to get signed up for that. I think it's like, ends up being £1.50, $1.50 a month. But you know, helps me keep going, both in terms for little things I have to pay for to do this, because I'm not really doing this for profit at this stage. So you know, it keeps me in deoxit and alcohol wipes and stuff like that, and most of all, you know, encourages me. You know, I feel like I've got backing by it and an obligation to enthusiasts to know that you're sponsoring me. I'm babbling now, but anyway, yeah, join Patreon, give me money. Thanks for watching. See you soon.